warm welcome back, and we're really getting into IoT. That was Matt Hatton from Transformer Insights, really setting the scene. And joining me now is Nassia Skoulikariti, who manages everything IoT related with us here at MEF. Nassia, great to have you with us. Hi.
Great to be here. Good morning, everyone. Hello, hello.
You've got
very exciting day.
You've got a few sessions coming up now.
I do indeed, quite a few, all IoT related. Really looking forward to all of them.
Absolutely. It's clear that IoT is real. It's not just a concept. It's very, very real. So I'll hand over to you and have fun with your sessions. Thank you, Nassia.
Fantastic.
Bye.
Thank you, James. Hello again, everyone. Nice to be here. Thank you for joining us. And next up, we have the IoT Global Connectivity session. Joining me today will be a tremendous panel of speakers. When it comes to IoT connectivity, it's a subject that can be quite difficult to grasp in many ways. And in this session, we're going to look at it in a more holistic way. So before further ado, I would like to introduce our panel. First up, in no particular order, will be Larry Socher, with the VP of Strategy and Solutions from SI. Hi, Larry. Good to have you with us.
Hi, Nassia. Hi, everyone. Larry Socher. I'm responsible for strategy solutions and alliances at SI, a global IoT connectivity company. Joined SI back in January of this year after spending the last 26 years at Accenture, where the last 8 I ran cloud and infrastructure offerings globally. Also ran the enterprise network practice there for 2 years, where I met Nick Earl, our CEO, who was running services at Cisco at the time, and was also lead architect and ran the service provider business for 12 years. So very excited to be with SI, helping overcome the challenges of IoT connectivity.
Great. Thank you, Larry. Let's bring Brian Chiu from China Mobile International. Hi, Brian. Welcome.
Hi, everybody. It's Brian. I'm from China Mobile International, based in Hong Kong. I am responsible for business development for the IoT business with our partner. So develop the business together with China Mobile headquarters, not just in Hong Kong, but also in mainland China. So this is my business role.
Fantastic. Thank you, Brian. Let's bring Alessio Piussi from Pod Group. Hello, Alessio. Alessio is the Director of Mobile Private Networks and Strategic Partnerships. Welcome, Alessio.
Yes, hi, everybody. Thanks for the opportunity of being here with you. Yes, I take care in Pod Group for strategic partnership and private network proposition. Besides that, I do have background around different IoT devices for telematics, asset tracking, fleet management, and then also in the automotive area. So it's my pleasure being here with you all today.
Great to have you with us, Alessio. And last but not least, Charles Bernard, the CTO of Zariot. Hello, Charles. Welcome.
Hello, Nassia. Thank you. I'm the CTO of Zariot. So we are MVNO IoT connectivity provider. And we are making sure that we have a very extensive control of what we offer to our customers, because we believe this is the best or not the only way to offer security and seamless experience for end customers.
Great. Thank you, gentlemen, for joining me today. IoT connectivity is such a big subject, and it's something no one can avoid or escape, for that matter, when they're getting started or while they're traversing through their journey of IoT connected services and products. So first question, I come to you, Larry, and let's get right into it. When we talk about IoT connectivity, we automatically think about cellular connectivity. However, the options are quite vast. What are some of the key considerations when we are selecting or looking to procuring IoT connectivity?
You really need to understand the application requirements. And I thought Matt's application segmentation in the previous segment was a great starting point. So how much data does my application have? What's the frequency of transmission? How critical is the application? Can it tolerate any downtime? Is the device fixed, or is it mobile? Is it going to be moving around? Does the device run on battery and require low power networking and optimization? So if you think about meters that may, gas meter that may have to be out there 15 to 20 years. And then very importantly, what geographies? This is a global deployment. Do you have to operate in different geographies? And only once you've got a handle on those application requirements, you can then look at the connectivity that's needed. And once again, Matt's protocol stack was a good example of that. So what radio access types are available? You saw the different low power WAN options that he presented earlier that will support the application. What kind of services do they need? Do I need to localize in order to support regulatory constraints or power requirements? So if you think about NB-IoT and LTE-M and their power save mode and EDRX power optimizations, often you need to be localized in a particular geography to support that. And then I think very importantly and often forgot is how do I future-proof my deployment? These applications are often out there in difficult locations for years, and it's a changing market. So you need the ability to do that. So do I need a fallback mechanism to counter changes in the operator agreements? Now, it often points to cellular, as Matt pointed out, but there are other options. So obviously LoRaWAN for low power. And I think with the emergence of Sidewalk and Helium, you're going to see growth in LoRa. Satellite's always been a good option, particularly for maritime and difficult locations. But it's going to get more interesting with the emergence of new LEO constellations like Starlink and the R17 providers like Skylo, where you can use existing cellular modems and antenna. And the other thing I think is interesting is we'll see a blurring of the digital home, particularly applications like telehealth, and their Thread and Matter are going to play a much greater role along with Bluetooth and Wi-Fi. So to anticipate over time, you'll want solutions that support multiple radio access types simultaneously, and ideally have the ability to dynamically select and optimize connectivity based on performance, service levels, power, cost, and other constraints.
Great. Yeah, that's the options are so big, and you mentioned satellite, which when it comes from the satellite perspective, I know that the operators on that spectrum they look at themselves as not competing with their overall ecosystems when it comes to connectivity, rather as partnering, so they can fill in the gaps where there's no cellular reception. Now, Alessio, is there any other key thoughts that we should be advising people when they're looking to select or buying IoT connectivity?
Yeah, to link back to what Larry just said, it can be really complicated and complex for enterprises to choose the right connectivity technology, right? And probably the best approach is really to, nail down the scope and understand for all the different business use cases which are the key connectivity requirements in order to be able to associate the best technology. And as Larry mentioned, it can become quite easy for an enterprise to understand at the end of the exercise that actually there is no one single magic connectivity technology which fits all the purposes, and this is why flexibility is one of the key parameters here to really, be able to scale globally and geographically, both on volumes and in geography, your solution, right?
Absolutely. So Brian, I'll come to you and ask you, how important is actually flexibility when we're looking at IoT connectivity? Alessio was just mentioning that it's key when we're procuring connectivity. How have you seen it from your end?
So I think so the enterprise is looking for flexibility in the IoT connectivity. They would like to have the flexibility on the life cycle management of the device and the solutions. So that's they want to adapt to the product in the future. So they want a IoT connectivity which is future proof, which is compliance to the regulations. So I think that's the enterprise is looking for. And I totally agree with the Larry as the enterprise there's many requirements. So I think the flexibility on the radio technology and the how they can manage the connectivity is very important.
Great, thank you, Brian. Charles, you coming to all this from a more technical background, being the CTO, and before I get into the next question, I wanted to see if you had anything to add around the flexibility and best practices from your perspective.
Well, there's so many things to say, so many things have been said, but Yes, flexibility indeed is a key element. I will also mention security, but after all, like flexibility, I believe for connectivity providers is what allow them to achieve security. I think there are a lot of connectivity providers that are too much locked into what they can offer because of the proposal of the MNOs they're relying on, and that's a key element. I think flexibility comes if you have control of what you can offer, and if you have control of what you can offer to enterprise, then you can also offer the security. And I will go back also to the future-proofness that Brian mentioned, with mentioning EU ICC, which I believe is part of flexibility. Offering EU ICC is a way, or the way to offer that as well.
That brings me quite nicely to the next question. I would say, Charles, and I was going to ask you, how does the eSIM, iSIM is shaping IoT connectivity?
Well, I always think it's my point of view is EU ICC, a bit like roaming actually, should be transparent for end customers to an extent. We provide connectivity and they should not really care how we do it. It should be the best in many ways. It should be seamless for whatever that could mean for them. So I think eSIM, or I prefer to say actually EU ICC, will bring a seamless experience. But there are also in the future for customers that will offer them a seamless experience. I think it has many entry barrier that needs to be removed to have a full seamless experience through EU ICC. However.
Okay, that's good, Larry. Connecting the eSIM and roaming a little bit, do we think, before we get into the nitty-gritty of the roaming aspect of IoT connectivity, do you think that the eSIM can help and aid to solve some of the challenges? Perhaps we can start talking a little bit about the roaming and then answer the challenges about that we can cover that.
Yeah, I mean, I think eSIM, EU ICC, multi-IMSI all help to solve the roaming dilemma, but they don't do it alone. So eSIM, emerging iSIM, and EU ICC give us increased flexibility on the device to switch mobile networks with remote SIM provisioning, but they don't alone solve the problem. You need to make sure that, when you're deploying something, you have the ability to support multiple IMSI profiles on a device. With bootstrap logic, not just to switch, but and ideally localize, but also if there's a network outage or if there's networks deprecated like 3G in the United States, you need to be able to switch back in the event of a failure. So you still need that on-device logic. That's very important. You also then you still need access to the mobile networks around the globe, and ideally in a way that you can localize. In order to support either low-powered optimizations or in countries that have regulatory requirements. So there absolutely EU ICC and eSIM and iSIM help that. And ideally you want to be able to manage your estate, with a single platform, and that needs to have very deep integration with different operator requirements supporting their preferred model. So if you look at EU ICC, different MNOs operate differently. So some in general allow you to load IMSIs directly onto bootstrap profiles, others using remote SIM provisioning and what's called the SMDP database that the SMSR pulls the profile from. Some will let you load the profile onto your database. Others require that you pull from their SMDP or database. So while it certainly gets us a long way towards solving the problem, between eSIM, iSIM, and EU ICC, and the key building blocks for helping us with the flexibility and if I look at eSIM and iSIM also lowering the device costs, they really need to be coupled with a global federation of mobile network operators and a world-class connectivity management platform to really unlock the value. So I think yes, they get us a long way there, but they're not everything.
Indeed, I would say that roaming is one of those areas where a lot of enterprises and even telcos alike find quite a few challenges, and the Eyese and Eyese and UICC will help with the multi-INSI environment to provide, I guess, a more flexible way to switch from one profile to another while the device is traversing or traveling from one location to the other. What are the, some of the other key elements that enterprises in particular need to be aware of when they're considering roaming for IoT connectivity? Alessio, can you help us with that?
Yeah, I would say another key aspect of this is the fact that also the cellular connectivity technology around the globe is really fragmented, right? As Larry was mentioning, there is some sunset around 2G, 3G, which differs from operators to operators, from country to country. 5G rollout is also not really homogeneous around the world, right? Mm-hmm. Or also on low power network technologies like narrowband, and other KTM, etc., right, where you have some geography which are mostly focused on one technology rather than the other. And this is another key aspect which, let's say, the enterprise needs to keep in account when they choose the connectivity provider which has capability of multi-IMSI or bootstrap in order to have the broadest coverage as possible around the globe, and also the capability to transform and download profiles over the air, right? This also helps in order to be flexible and to simplify global scale deployments.
Great. So, Charles, at which stage do you normally advise people to start looking at connectivity? Because in some cases, it's an afterthought. Okay, I have my connected devices. We've seen a lot of the projects getting to a stage that, I now need to find a connectivity element. So, and it's a question that came through from our audience as well. At which stage? Is it at the beginning? Is it while you're there? So I would like to know, because you've done quite a few of them, what would you advise them?
Well, I think it depends also. It has to go back to what is the technology that the customer wants to use, and they can only see that after testing a little bit based on the consumption, the application they have. As Larry said, it all depends on the use case. So there will be, if you want to go for cellular or non-cellular, I would say that from the beginning, you need to do that from the beginning, because it's such a decision. I mean, such an impacting solution decision to take, that this one has to be done from the very, very beginning. Then, if you want to go for the challenge, is that once you go into cellular, one can say, you can always go for 2G, 3G, 4G, and so on and so on, and or LTE and or NB-IoT. And here again, that's something you can probably decide at later, at some stage after doing some testing and being sure that you are satisfied with the coverage, and depending also use case you have of data consumption by some technologies or others. But here comes a large problem here that I must say I don't have the answer, considering the 3G sunset, the 2G sunset that you have, NB-IoT roaming, which is actually have been told by so many customers that NB-IoT just doesn't work. I used to come from roaming. Roaming works, but NB-IoT roaming just does not work as other cellular technology comes. So here, can an enterprise bet that NB-IoT roaming is going to get better? So all in all, to go back to the question of where, I would say that if you have to take a decision if it's cellular or non-cellular, take it from the very beginning. But then the cellular technology that you want to use, try and see which one, depending on the use case. And the consumption, you can only know it if you really do some testing.
It's an outstanding question, Nassia. If you actually look at it, there's a stat out there that 80% of IoT projects fail, and it's often because of the device. We always underestimate the device. You look at 5G right now, we can't get devices, right? So, and you really have to, from day one, design connectivity in the device. Doesn't matter how good your federation of networks is, your RSP capabilities, if you don't design the intelligence and connectivity in the device. So got to be looking at that and saying, hey, am I cellular? Am I low power? Do I need other protocols? I think increasingly with modem prices going down, I can get a sub-gigahertz radio and complement with, you know, LoRa and other technologies. And what's interesting is that one of the things we focus a lot on in SI is actually helping our customers and partners with their device design. So how do you design from day one connectivity, flexible connectivity, insurance policy, whether it's switching networks or even radio access types, and build that into the device with resiliency, which is really important. If I'm going to put a meter out there for 15 to 20 years, you know, and it costs me $200 or $300 to go and service that meter for replacement, that blows away my business case. So I really need to design the flexibility to communicate with different networks, with potentially different technologies, and to do that over very long periods because of the, you know, how long IoT devices are out there. So that upfront device design is, you know, one of the most critical things to get right.
Well, I would take it even a step further than this, or which is deciding what the problem is that we're trying to solve, right? When we're connecting and creating the solution, because based on the problem and the challenge, then we will decide which are the right devices, and therefore, based on that, what is the right connectivity? Because in a lot of cases, we might need more than one type of connectivity. In certain areas, will be cellular, where cellular reach is not available. It could be LoRa with backhauling into satellite, and so on and so forth. It's very I would say use case specific. So when we're looking at how and what in IoT, is starting at the problem, at the core. Why are we designing this? I don't think any of us or any company out there gotten into IoT just to have a laugh, right? To have fun. It takes a lot of time. It's very complicated, and it takes a lot of resources. So designing and understanding from the get-go, from the beginning, it would help, and it will save a lot of grief in the long run. So, Brian, I'll come back to you, and I would like to understand from your perspective, being at China Mobile, what are the areas that you see your customers coming to you? At which stage do they engage with you? Do they engage from the first beginning, or is it you know, midway where they come, or can you help us with connectivity, or can you help us with, you know, the end-to-end ecosystem?
Okay, so actually, my team is more on the road to cooperate with our MNO partners. So most of our customer or partners from the MNO side. So they're kind of reselling China Mobile connectivity to the enterprise. So when they come to us, most of the case is in the later stage or in the middle stage. So they would like to discuss with us for kind of they kind of looking for the options for the connectivity solutions. So not just for one single solution. So you know, for IoT global connectivity, there are many ways to achieve that. So and you know, back to the topic about roaming. So you know, roaming is already in the market for such a long period, for tens of years. So most of the MNO already deploy the solution using the M2M or IoT roaming. So they already deploy the solution, and then when they come to us, normally they are looking for some specific use case. For example, is the automotive OEM. They want to deploy the solution in mainland China or even in Hong Kong. So they want some specific solution which is suitable for the enterprise customer in many ways, like in regulations point of view, in the permanent roaming, whether it's possible or not, is regulatory allowed us to deploy. So this is most of the case we are facing now. So I think now we need some we need to be very flexible in providing different IoT connectivity solutions to our partners. So not just roaming, but also we're now considering the UICC way. Actually, for China Mobile, we have already have the capability of UICC few years back. So we have cooperated with our partners, and we have commercially launched this product. but I think the main reasons that maybe the technology is not that mature, or maybe the commercial model of the roaming is too favorable to the enterprise. So that's why they still stick to the roaming solution, and then the take up of the UICC is a bit slow. So that's the current situation now.
Thank you, Brian. Alessio, can we really ensure a seamless end-to-end IoT connectivity? What have you seen from your, exposure, I would say, in different projects?
Yeah, generally, this is one of the aim, especially from an MVNO perspective, because the idea is really to enable enterprise to have the broadest coverage as possible and the possibility to roam across different operators and technology. Clearly, one of the components or elements of it is the multi-IMSI approach and the bootstrap, where you can provide connectivity, for example, from a pod perspective in 185 countries with more than 600 different networks across any type of technology. Another aspect of it is also, which is becoming more and more important in the future, is also seamless roaming across private and public network, for example, right? Because private networks are taking over in many different geographies for many different verticals, and also having a SIM card like the Pod Inno1 SIM cards, which can roam seamlessly across private and public network, will become in the next future a key element of it. So yeah, definitely seamless is the challenge over the next months and years, and how quick you can switch between different networks, and how, let's say, broad coverage you can grant to your customers.
Thank you, Alessio. Staying with on this track, Charles, I mean, we can escape talking about 5G a little bit more when we're talking about IoT connectivity. So how do you think 5G, as it expands in terms of usage, will affect the overall connectivity for IoT? You're muted, sir.
All right. So I think for the 5G, I mean, I have my take on 5G for IoT. So 5G has been the promise of global deployment of 5G of IoT, but we've seen so many deployments already going out there without not waiting for 5G. So and I think 5G will be there for some niche business case that requires super low latency or rural broadband access, but if you could talk to a company who is willing to go for meters and have millions of meters, they're happy with 2G. And even talking with some friends working on 5G and some operators, and they're all saying that, yeah, 5G, the business model is tricky, but for business, a specific niche case, yes, they will be there for. So I don't think it will change the course of massive IoT adoption. But it would be useful for some edge cases.
Great. Larry, I saw you shaking your head.
Yeah,
right? So
I agree.
Come to you.
I mean, obviously, there's a lot of hype about 5G, and it enables some incredible use cases. You look at augmented reality for telemedicine and stuff like that for ultra reliable, low latency. But I agree with Charles. I actually think most use cases really don't need 5G yet. Now, I do think you need to start building the foundation to support it. Great example is that, there are emerging things around autonomous vehicles. So autonomous vehicle in a mine, if I can get a driver out of the truck, I can go down a steeper grade and with half the blasting get the same yield out of the mine. So tremendous business case. That gets me into a 5G URLCC use case that's out there. Now, what do we need to do to support that now? Obviously, the cellular networks will be able to support 5G going forward. But to do an application like that, you're going to need to have a software-defined network backbone. You're going to have local and regional access to cloud data centers with very low latency. So how do you build a global backbone network, ideally software-defined with global POPs that can integrate with 5G network slicing? So I agree with Charles that we're not seeing as many of those use cases yet, at early days. but you need to start to lay the foundation so that you can do that end-to-end QoS and security, which is a big part of 5G. So at least put the building blocks in place and how you deploy, LTE, NB-IoT, and other technologies with the groundwork to do network slicing integration at the end.
Great. Yeah. And Alessio, earlier you mentioned a little bit about private networks, which connects quite nicely with the whole 5G story. You've been involved in private networks for quite a bit. So what are some of the key considerations we should be looking at?
Well, for sure, there are a couple of key elements to be taken in account, right? One is definitely the spectrum, which is one of the key, let's say, component or key challenges of this kind of solutions, right? There are some countries, especially like USA, which are driving this with the shared spectrum CBRS, which simplifies the deployment of the whole country. There are some other countries which are, let's say, studying a solution for licensed spectrum, like UK, Germany, which simplifies the deployment, for example, in transportations application like harbor, ports and airports, or for industries. And together with the, let's say, spectrum part of it, which is one of the key challenges, is really the general complexity today of deploying a private network, right? Where you have a consistent ecosystem and different player. And this is where probably the system integrators will take a role, or service provider, in terms of supporting enterprise to build this sort of ecosystem. And from our side, from pod perspective, one of the key topic is removing this kind of barrier, right? Simplifying the adoption of a private network by having, for example, a single platform, agnostic platform, which enables to manage your private and public networks, and a SIM card which can support the roaming across private and public network in order to extend end-to-end the solution for and the application for enterprises. I believe, yeah, those are the key considerations, really. It's around how we can simplify in order to enhance the adoption of these kind of technologies and the scalability of this technology on a global scale.
Just to add on to, and I agree with that simplification. Particularly, it's hard for an enterprise to put in a Open RAN deployment or something like that. But going back to the device, I mean, a lot of things that are holding up private networks right now are the devices. So let's say CBRS in the United States, having the IoT devices that can talk those frequencies and getting them certified, et cetera. So particularly if it's PEL license, which requires certification. So I think. We are seeing a big, we're starting to see an uptick in adoption. I take it, Alessio, you're starting to see quite a bit right now, like in manufacturing, mining, warehousing and stuff. So we're definitely seeing that. But I think, accelerating the device ecosystem is going to be a big part of that, so that we have things that can actually talk to these private networks and use some of the shared spectrum that's emerging out there.
Great, thank you.
Connected to the device, there is also the aspect of end-to-end security of the solution, right? Yeah. Because of course the private network is an isolated, let's say, environment, but the solution doesn't end up there. You have devices, you have situations where you need to roam into the public connectivity, and the challenge or the question here that also we resolve from both sides is how can you, let's say, ensure end-to-end security from the device and data integrity, from the device through the network, private and public, and then into the cloud or into the platform.
Great, and you bring me quite nicely, Alessio, to the next question that has to do with securing IoT connectivity. And I know, Charles, you folks at Zariot has been looking quite heavily on how to secure IoT connectivity. So I would like to get a few highlights of what are the key elements, and are they scalable, really? Can we secure connectivity, and can it be scalable?
Well, I would want to say yes, of course. It has to be we can secure, and it has to be scalable. It is not easy indeed. Well, I mean, all has to be come in mind as with security by design. Sorry, not only at the network level, but also at the SIM or the device level. So I'm sure that Larry has put an effort by designing the device to make sure that they're secured for their customers, and that's one way also that's a way to do it. Also on the SIM level, we provide authentication at the SIM level with the partners, the at-sign company, and we also look at different levels of security at the signaling, and then encryption end-to-end, and make sure that access is control of who can access the data of the end customers. So those are different aspects. I mean, everything that has to do with the confidentiality, integrity, and availability of the data. Scalability is a challenge. Has to come with a cost. If you want to have for me, the challenge of scalability is that, are you willing to make it scalable? Are you willing to pay to make it scalable, I would say. And that's something we see that customers, they want secure, but they want it cheap. So we tell them, you can have it cheap security. You will have to pay for it. And then comes from I think there's a bad habit of having connectivity seen as something cheap and a commodity. Security would have to fight back against that to prove its point that it's doable and it has to be done.
I do think most of the building blocks for security are there. It's really piecing them together, which as we know, is not easy. But locking down the device, and protecting the bootstrap connectivity and applications. If you look at the SIM technology, you look at ARM Trust Zone and all that. So we have a lot of the elements to, the secure enclave to do that. Providing the device to cloud micro segmentation. So we have our APNs, all the way through an SDN and global network, regional POPs into the cloud, and cloud networking security has improved dramatically, with Amazon VPCs and stuff. And then, a lot of the management, including firmware and patches. You heard Matt talk about lightweight M2M really helping that out and starting to over-the-air updates and patches and stuff. And then, the ability now to take a lot of that device and network information and provide it to a SOC and SIEM, including IP address resolution. So I think all the building blocks are there. It's just, as with security, it gets just very hard to make sure it all fits together seamlessly, and will never be done, right? I mean, there's always bad actors and trying to stay ahead of them.
Indeed.
But I think our toolkit's getting better.
And we have a session later on today to talk particularly about IoT security. And folks, we are just on the last minute of our session. It went really fast, and there's quite a few more questions that came through the audience. I would like somebody to jump in and answer in closing. Which approach do you think is better for IoT development? Telco approach, IoT brand manufacturer, or vice versa? Who would like to take that?
I mean, my general is everyone has to work together. You can't, it's not one or the other. I mean, these things need to interoperate. We're not going to do it without the service providers, but we need the device knowledge. We need other technologies. I think the whole thing, if you look at IoT, I mean, I've been doing system integration my entire career. I've never seen anything that's more system integration, more moving parts that need to work seamlessly together to deliver it. And it's not one or the other. It's both working together.
Exactly. And I think this is a good place to finish, folks. We're on the top of our session. And the key takeaway is work together. It's a complete ecosystem. Can't do it alone. So let's work together to provide a more seamless and flexible and easy to use IoT connectivity. Thank you very much, Charles, Brian, Larry, Alessio. It's been a great discussion. Thank you for joining us, and thank you for watching us. Thanks.